Assalamu alaikum. In this video on optical fiber introduction, this is the part three of my videos. We will see that what technologies uh, are we running over the optical fiber network. Basically, if you can recall, this is the third part of my series on optical fiber. The first part was on the light and glass, where I provided some characteristics of what kind of glass and the light source is being used in optical fiber, because optical fiber is basically a strand of glass and we use light for communication between 2 points. In the second video, I go in the detail of the characteristic of optical fiber cable, and I at the end we make a link and we did some link budget. And now in this third video I'm touching on the technologies that are being used on optical fiber network. So even though it's better that you go through my previous videos as well on YouTube on my channel, but if you want, I mean, all these videos are part of the series and they are standalone as well. You can watch this video fully and then you can watch the other videos to recap everything. So let's move further. The first technology that we will discuss was a de facto transmission standard, and still it's a de facto standard in some part of the world, and especially in the very long haul networks, which are the submarine networks. You can find still STH as the main de facto standard, and the reason of using STH is it's very easy to operate and administer and maintain, because you have a lot of expertise available, a lot of people you can find who can work easily on STH, and it has traffic protection schemes, and there are a large variety of client interface that are supported, and to extract a channel or to put a new channel is very easy in SDH. And as you can see here that it supports the IP networks, it supports IP, and it supports ATM. ATM is now not too much used, but still there are some ATM legacy networks, so you can directly put ATM over SDH on the VC4 layer. And the normal E1s, which were part of the initial telecom networks, now I think E1 is not used a lot. It's used very less now, but still E1 is very simply, it can be used on SDH. So it can take many different kind of interfaces and it can map it to different SDH layers, and then it can multiplex it, and it can send it to the physical optical fiber interface. So how SDH is made? For example, if you have the low capacity client interfaces like 2 megabit E1 network, or the DS1, which is used in the US, E1 is used in almost all of Europe and this our subcontinent and Gulf, and DS1 is used basically in the USA. So you can, for example, if you have a client of very low rate, then you can multiplex several clients. You can multiplex 63 clients or 63 E1s to make one STM1. Or if you have a STM1, then you can directly map this STM1 also. And if you go further, I mean, if you have a STM4, or because STM1 is 155 megabit, so if you have 640 megabit, then you can directly put it on a VC4. Or then if you have a 2.5 gig, because 2.5 gig is is more used somewhere now, or 10 gig is, we can say now in Ethernet 10 gig is very much used in most of the networks. So if you have a 10 gig, you can directly put it on VC64, VC464C, or we can call it STM64. And if you have a more bigger, a 40 gig network, then this 40 gig can also be put on STH. But now the support of 40 gig is not available on STH very easily. So you have to shift to the new standard, which is called OTN, and we will discuss it further. But if you see here, these boxes have different colors, so they have different meanings. Like for example, this is a simple container. Container means that it just take the data and put it, like you put it in a container. And here we are doing some pointer processing. It, like for example, when you put something in container, then you give it some kind of addresses, that okay, what kind of data is this is and where it has to go. So for that you add some pointers. So here you add pointers, and then you can group different containers with different pointers, and then you send it to the physical layer. You send it on your optical fiber cable. So this is how STH, it maps the data from client source towards the line, or towards your main network. So pictorially, if we see, if, for example, if we have a box, then we can say that on one side of the box we have tributary ports where we connect with the clients, and then we have the line cards, which is going towards the network, towards your other nodes or other sites, and in between we have a switch matrix or a cross connect. So through this cross connect we can put any tributary on any line card. We can take a tributary from here and we can put it on this line card or this line card or any of the line card. So we can take any service and we can take it to any line side. But in one thing in SDH is that you cannot overbook. I mean, if you have a client of 10 gig, then you can put exactly 10 gig over it. You cannot put it 11 gig or 12 gig or 14 gig like generally we do in packet networks. So a TDM network is generally there are some boxes and which are connected through fiber. This black color is fiber. So these boxes are connected to each other, and then you make, if you want to send a service, for example, and a 10 gig service from this point to this point, then you make a service which is passing through all these intermediary nodes, and then it's going out from here. And you can, if you want, you can make a protection of this service. Protection should take a different path. So for example, service 1 is protected on the protection 1, and the service 2 is protected on the protection 2. And if there is any cut on this service, it will be automatically protected on the protection link. But if you don't build a protection, then this service will not be protected. So it's not like that everything is inherently protected. I mean, you have to protect it if you want, and if you don't want to protect it, you cannot, then you can leave it as an unprotected service. But if you have different services, then each service has to be protected separately. But in terms of packet network, you first make a tunnel between the endpoints. Like for example, if you have a network almost similar to the previous one, and you want some services to go from this point to this point, from this node to this node. So you make a tunnel between these two nodes, and on the other path, on the second path, you make another tunnel, but this tunnel is, this is the working tunnel and this is the protection tunnel. Now whenever you will add any new service, and you will ask the service to take this tunnel. So this service will be established between these 2 points automatically because the tunnel is between these 2 points. And whenever this working tunnel will fail, the protection tunnel will start working. So all the services which are taking this path going through this working tunnel, they will be automatically switched to the protection tunnel. However, if this is part of a big network and you have different kind of tunnels going through this different boxes, then maybe this you don't find enough capacity for the production. So maybe if your working is tunnel is using 10 gigabit per second, then maybe your production has only 5 gigabit per second. So if there is any failure here, then all of your services will not be switched because you have a disparity between the working and the production. And even in this packet network, you can overbook the working as well. So maybe working is not taking only 10 gigabit, it's basically taking a services of 12 gigabit, and you have a protection of only 5 gigabit. So you can assume that in that case, if there is any cut here, you will have a lot of congestion on the production path, and only the service which are given the highest priority, only those services will continue. All other service will face a lot of problem. So now we can see that what are the differences between TDM and the packet. In the TDM, we have a dedicated end-to-end network resource. If you make a service, then end-to-end resources are available. But in packet, you share the end-to-end network resources. I mean, you make a tunnel and then you can share the services on that tunnel. But in TDM, we don't have QoS. The reason that we don't have QoS is basically because we dedicate all the resources. So that's why we don't have QoS. But in packet, because we are overbooking, as we are overbooking, so we apply QoS so that we can tell the system that okay, in case of any congestion or any cut, which services will have a priority, which service will have a high quality. So in TDM, all the traffic has almost the same priority, except if you are using some unprotected traffic. Unprotected traffic will never be protected. But in packet, almost all service has to have some quality of service associated. So if you have a gold service, it has a very high priority, but if you have a bronze service, then it will have almost no priority. So it will be dropped in case of any congestion. In TDM, you can have rings which are based on MSSP or SNCP. And in packet also you can have ring, and these rings can be based on tunnels or RPR technology. In TDM, we have a fast restoration for all the protected services. In packet switch, we have a best effort restoration based on traffic class. If you have a very high quality, very high QoS traffic, it will be protected, but the low priority traffic will not be protected on the same 50 millisecond scenario. It may be restored if there is any available bandwidth. In TDM, the architecture is non-blocking because there is no overbooking as well. In packet switch, the architecture is inherently non-blocking kind of, but if you overbook, then you can have congestion. In TDM, we have a switch matrix which is TDM based, so granularity is on STH or SONET like VC11, VC12, VC3 or VC4. In packet switch, the matrix is basically packet matrix, so granularity may be based on packet, or it may be based on SDH or ODUs as well, but mostly this is based on the packets. Now we should see the automatic protection. The previous protection that we see was, you can say, it was a static protection. If you have put the automatic switched optical network in your system, then your system will try to protect the network as much as possible. So for example, if this is your network These are the optical fiber connected, and you have ASON enabled on your network. So for example, if you put a service working from this side, from the upper side, and a protection from the lower side. So assume we have a fiber cut. So as soon as the fiber cuts, your main service is gone, but your protection is already there. So your working will be shifted to the protection. So now your working and protection will be working on the same fiber. So what ASON will do, that it will remove the protection, because now protection and working was on the same path, but it will start calculating another path to make a new protection for you. And as you can see that, okay, this part we have no protection available because this is now a linear path, because the other side is missing. But for this ring we still have one more path available. So ASON will make a protection, and it will protect at least this part of your network now. Now if you get another fiber cut on this part of the network, at least this will be protected from this new protection path. So for example, in this network you can avoid two fiber cuts if both the fiber cuts happens in different rings. So it will save you from two cuts. But the static protection, like we see the last time the protection that we saw, it can save only one cut, because after one cut the system will not automatically start to calculate a new path for the protection. But the ASON, the good thing of ASON is that until and unless there are some resources available, it will try to calculate a new protection path, and it will try to keep your network always in protected shape. So the next technology, which is quite famous, is the DWDM in the long haul networks. When you connect between, you can say between countries, or if it's a big country, then even between the cities, you have the DWDM network, and then within the cities in the metro you can have CWDM networks. So CWDM and DWDM, they are wavelength division multiplexing networks. So in these networks, the wavelength that we have is divided uh, in with very small, you can say that we have very small channels, and each channel is can carry a payload of 2.5, 10, 40, or even 100 or 400 gig. So for example, if like we write here that for example, if you are using a DWDM which can support 192 channels, because if you use both C band and L band in DWDM, then you can make 192 channels out of this spectrum. And if this is going on 100 gig, so it means that you have almost 19 terabyte of capacity. So DWDM can give you very high capacity, and on the client side it can take almost all majority of client of SDH and Ethernet. But the only issue of DWDM is that its implementation and operation is a bit complex, because you are working directly, you are multiplexing different light channels, and it's a bit, you can say it's a bit difficult to manage, because if you don't manage it properly, or if there's a lot of changes in your network, then you can have a problem. But generally, if you have a universally accepted wavelength grid, if the channel that you are using, if they are all as per the ITU recommendation, then the good thing in DWDM is that you can very easily connect different vendors' equipment with each other. So the good thing in DWDM is that it gives you very high capacity, and you can easily connect different vendors, and you can use it on a very long distance. So that's why DWDM is widely used on the long haul networks in within countries or out of the countries as well. So why we use DWDM, why we don't use SDH again and again. So for example, in this example, if you have a traditional 10 gig SDH network and you need to provide 40 gig to some customer between two locations. So like here you can see that if you have a 10 gig client interface, then to go to 40 gig you need 4 fibers and you need 4 terminals here, and because in SDH we cannot go very far because we are using 1310 as well. So for example, if you're using 40 kilometer hops, then you have to use 32 regenerators if the link is very long. For example, the link is almost 300 kilometers. So you have to use 8 regenerators in every span. So in total you have to use 4 fiber pairs and 32 regenerators. But because the transmission in DWDM is more advanced, so one thing is that you can very easily multiplex all these channels on a single fiber, and you can go a bit higher distance because the amplifiers in DWDM can go further than the SDH network. So in this case we can use only one fiber pair and we will use only 4 optical amplifiers, and we can achieve the same like 40 gigabit and a distance of around more than 300 kilometers. So this is why DWDM is more beneficial for us. This is a flow diagram of DWDM. For example, if we traverse in one direction, because you can say that this is one direction from here to here and the same one direction from here to here. So if you understand one direction, then the other direction is almost the same, but it is from the other side. So we put the client signal on a transponder. This transponder should be based on the client requirement. I mean, for example, we can have a TDM transponder. We can mix it with a Ethernet transponder, and we can have, for example, a 10 gig transponder, and we can mix it with a 2.5 gig or a 40 gig transponder if the design allows. Sometimes it is not easy, but sometimes it is very easily possible that you take different sizes of client signal on the same fiber. So you can mix and match as well. So we put different clients and then we mux this, we multiplex all these client signals and we multiplex them on a single fiber. So this fiber can, if this is a fully designed network, it can take 192 clients on the client side, and these 192 channels can be multiplexed on a single fiber. And then as per requirement of our network, the size of this span, we should use some optical amplification, and then we should send this signal out. So if we have a bit longer span, like for example 200 kilometers, and we need line amplification in the middle, then in the line amplification we will not process any client signal, we will only take this light, and this light will be optically amplified. So there should not be any optical to electrical conversion here. I mean, you can amplify light in the light domain, in the optical domain. So that's why these are very fast as well, because there is no any processing. The light goes on the speed of light. I mean, there is no conversion. So you just amplify the light and then you again send it out. On the receiver side, you receive, because this signal may be very low, so you may need to pre-amplify before sending it to the demultiplexer. So just as you multiplex these signals to multiplex 192 channels on the single fiber, so here from this single fiber you can take out all these 192 channels and you can provide it to your clients on the receiving side. So the same will happen on the other side as well. So technically you can say that this is one side or one direction, and this is the other direction, but the working is exactly the same. That you take the channels, you multiplex them, and then you amplify them as per requirement, and then you demultiplex on the other side. So this is the working of a DWDM system. This is a sample network. For example, if you have a big optical fiber network like in Saudi, this is the Saudi National Fiber Network, and you can see that there is a lot of fiber, and there are DWDM networks which are connecting the main cities of Saudi with each other. And also the same fiber is used to connect to other countries, like for example from Batha we are connected to UAE, from Jizan we are connecting to Yemen, and here from Qurayyat we are connected to Jordan, from Arar we are connecting to Iraq, and from Khafji we are connecting to Kuwait. So Saudi is connected through land to many operators and many countries, all the countries which are its neighbor countries, and all these connections are on DWDM, so you have very high capacity connectivity. And this is a sample network on how does it look like on a network management system. So you can have a lot of connections if there is a big network. And like here there is a sample of a city like Riyadh. So in Riyadh also we have optical fiber within the city, and all the data centers are connected to each other on the same DWDM network as well. So the OTN, as you can say, is the future technology. It is a kind of mix of DWDM and SDH. Here we have the same, like we had the mapping in SDH, we have the similar mapping, similar to SDH, that if we have a client signal and the line signal is a bit higher, then we can multiply the client signal. We can have two client signals for this line signal, because the lowest line signal in OTN is 2.67 gigabit, almost 2.5 gigabit. So if you have one GE as a client, then you can multiplex two of these clients and you can fill this. Or if you have a 2.5 gig as a client or STM16, then you can take it directly to 2.5 gig, and then you can multiply this 4 times to make a 10 gig, and then you can again multiply it 4 times to make a 40 gig. Just almost same like in SDH, we can multiply 4 times and 4 times, but the difference comes on 100G, because now 100G is not 4 times multiple of 40G. So from 40G in OTN you can go to 100G, and from 100G you can go to 400G. So I will not go in too much detail of OTN or each of these technologies, but just to let you know that OTN is the future technology now, which is being used a lot in the networks which are very advanced in nature. So the good thing of OTN is that you have a lot new features, like for example you have the GMPLS control plane, so you can very easily put the network to run on its own. It will find all the bandwidth limitations and it will distribute the traffic so that the traffic will go in the best possible way through the network. Your network will always be well optimized, well maintained if you let it run on its own. And it can also protect very much better, because it can protect you against many fiber cuts, because the protection is also automatic. So whenever it finds any fiber, any resource, it will automatically protect your network. And if you want to go in the 100G and 400G path, then the only way is now OTN, because on SDH there is no research and development going on. SDH is fixed on 10 gig now. Even 40 gig is not easy to be implemented in SDH. So you have to come to OTN. if you want to go on a high capacity client size. So after OTN, this is GPON. GPON is a gigabit passive optical network. This is a network that most of us are now using at our homes. This is the fiber to the home network. So basically this is a passive optical network. All the network from OLT to the ONT. These are the limits of the network, the boundaries of the network. One side of the boundary is OLT, which is in your provider's building, like the operator's building, and the ONU or ONT is on the subscriber side. For example, this is your home, your TV, your PC, and if you have a VoIP phone, they are all connected to the ONT. Some of the ONT they support a normal phone as well. They convert it to the IP within the ONT itself. So your all the services, I mean you have triple play services on the ONT, and from ONT to the OLT, this is all passive network. There is no power being used here. So it all depends on the splitting and combination of different clients. So for example, this OLT is sending a wavelength downstream. This wavelength of 1490 nanometer is being received on all the ONTs. So whenever it sends any user's packet, so only the user which this packet is destined to will take this packet. All other users will reject this packet, because this packet will be received by all of them, because it's a passive network. So anything which comes to this splitter is simply splitted. Same signal is being sent to all of these clients. So this is splitters, they simply split whatever they receive. So the split ratio of first splitter is generally 1 to 4. I mean, whatever is going out, you split it by 4. And when you go towards the client, near to the client, then you split it to from 1 to 32 or 1 to 8 or 1 to 64, depends upon your design. For example, if you are bringing this fiber to a small road which has only 4 or 5 houses, then you can put a splitter of 1 to 8. But if you are bringing it to a building which has a lot of offices, then maybe you can put a splitter of 1 to 64. It depends upon what design you make. But the one thing is that you can send the power of almost up to plus 5 dB maximum, and you can receive it on minus 28 dB. So you have to remain within the budget of almost 30-32 dB. So if you go beyond, then your signal will be lost. So generally this gives you a distance of approximately 20 kilometer. So between the OLT and the ONT, you can go maximum by 20 kilometers. And also this, because it's called GPON, gigabit PON, so the uplink is almost 1 gig and the downlink is 2.5 gig. But there is a new version also, it's called XGPON or 10G PON. So 10G PON has 10G downlink and 2.5G uplink. So if you have a GPON, then and you put a lot of customers on this GPON, then these customers may face some kind of congestion at the peak time, because if you put a lot of customers here, then 2.5 gig, even though it looks a very big number, but it will not remain very big, because if all the people they are downloading some heavy files or watching some movies, then they can congest your network. So planning the network is not easy. I mean, you have to see a lot of issues. I mean, you may be facing a lot of issues if you don't plan it properly. So because it is passive, so you can only manage the OLT and the ONT. You don't know what is going on in between. So that's why it's a bit, you can say if there is any customer is down, then you cannot know very easily that he's down on this splitter, on this splitter, because these are not managed. These are all passive. This is all passive equipment. So this is GPON, which is our last technology. So I hope this video should be beneficial for you. You should have learned something on optical fiber. uh, if you have any specific question, you can comment on the video, and if you have any other question, you can write to me. I will reply to you, inshallah. And you can connect to me on LinkedIn, and please subscribe to my channel, and please like and comment and share my videos if you like them, and hope to see you in the next video, inshallah. Assalamu alaikum.